Welcome to part 4, you made it. I skipped to the 5-minute mark if you want to see the rotors actually being turned. Otherwise, I have a few more steps to do to get the mandrel fully prepped before we get started. So with 2 drill and tap holes and 2 bolts bolting the first rotor to the mandrel, I went ahead and indicated this face because the wheel will actually sit against this face and the wheel studs will stick through the holes out as you would on a car. So I zeroed in right at this position next to this bolt. However, when I rotate the chuck around to the opposite side, it's out by 7 thousandths of an inch, as much. So to see if I can mitigate for that, I will do a third drill and tap hole. Make sure the rotor is fully flat against my puck piece. And I've been drilling tap these holes with the mandrel still on the lathe because I don't want to take it out because it will take everything out of the current setting that it's in. This is running true to the puck face, and everything should be good to go. I'll just do that third tap hole, see if I can get this face to run a little bit more true before we actually start. And I will step on the foot brake of the big lathe here, just to be absolutely sure that the lathe doesn't kick on, even though it's in neutral, it's not in gear. Or sorry, it's not activated by the on handle to my right. Because when you step on the foot brake, as my phone flops back into the actually perfect position, when you step on the foot brake, you'll hear a click, or I hear a click, and that means that if you tried to activate the lathe, it would not work because there's some sort of disconnect switch when you step on that foot brake. So I'm just hand drilling because I forgot to do this step. If I would have thought while the puck was not pressed on to the shaft of the mandrel, I would have laid the puck down into one of the brake rotors, took some marks for where the holes would go, and I would have actually put the puck in the vise in the milling machine, and then just use the milling machine basically as a drill press, and drilled straight down on the 3 holes, and then run the tap down through the holes while I had the puck in the milling machine vise. But I didn't think of that, so my backup plan to not have to take my mandrel out of the lathe, out of the chuck, is to just drill in place. And there I cut my finger on the last go through with the drill. As soon as the drills went through all the way through the whole drill motor slipped, of course, because there was no more resistance, no more hole. The hole had opened up, and then my finger barely nicked the outside end of the shaft of the mandrel piece, and then I had to go and get a band-aid, and it just took forever, just wasted time really, and I just barely nicked my finger. So now I'm running the tap through the puck of my mandrel piece, and this is the 3rd hole, so that the brake rotor can sit nice and flat against the face of the puck, because with just 2 holes, it's not enough. Maybe I really should have done 5 holes. My coworker did suggest that to me after I had finished. So I know that for next time on the other 2 rotors that I'm going to have to do, which are a different size. Okay, so the 3 holes are done. And yes, I am running the tap through with my adjustable, but you know what? I'm just trying to get this video underway because the turning is going to take the longest time because I'll be at a really slow feed rate. And plus, I can't have this piece in the chuck forever because my other coworkers are going to actually have to do actual jobs using this lathe turning material. So we got our first rotor up in the mandrel, and I bolted up. And I'm just going to go around and do some even tightness. So I'll just tighten the first bolt a little bit, second bolt a little bit, third bolt a little bit, trying to get it just a little bit and close in how much I tighten on each of the 3 bolts. And I'll just keep going around. And now I'm checking it with the indicator, and I'm indicating off the face of the brake rotor hub where the wheel would bolt up to. And then once I only got it within about 5 or 6 thousandths of an inch. That's how much run out I had. It wasn't running perfectly true. Yeah, so it wasn't running perfectly true. That's the closest I could get it. So I'm just gonna have to roll with that, because either the brake rotor, because it's warped, also the face is slightly off, or it could be that I needed to do all 5 holes in my mandrel puck. But I got the mandrel puck faced flat. I got the shaft running true, and I never took that mandrel out of the lathe until after I finished all 4 of these rotors. So 6 thousandths, I have to live with that, and I ended up getting that on the other 3 rotors. The third rotor I did was almost true. It was almost dead nuts on the money. It was out by like 1 or 2 thousandths, which was the closest one. But of course, once I finished turning both front and back of every single rotor, and I had done a full face cut, and the tool wasn't skipping at all. Once I got everything done, then I would take my 1 to 2 mics, and I would mic all the way around at like 6 different points around the thickness of each rotor, just to make sure I was getting the same reading down to 1/1000th of an inch all the way around, which thankfully I did get on all 4 rotors, because as of the voice recording of this video, all 4 are done, and paint is almost done. And then I could package them up, put a light film of oil on the rotor face where the brake pads will ride, and then I will be ready to deliver them to the person who, I guess, commissioned me to do this for them. Yeah, I guess I could say that, because that's honestly what happened. They said, I'll pay you to resurface these rotors, and I'll try them out, or I'll have them as backups. And I was like, all right, let's get her done. So I set up an indicator because my coworker also suggested that to me on the way or the bed of the lathe. Is it called the way or the bed? And then I touched it to the the saddle. I think it's called the saddle. The thing you actually, when you grab the handle and crank it, and it moves the whole saddle towards the piece in the chuck, or it can move it. The other handle will move it, your turning tool, across towards the back of the lathe. So I touched the indicator against the saddle, and I just cranked the handle over just a little bit. But I wanted the indicator on it, like my coworker suggested, so I could feed in exactly 10 thousandths, and not a little bit more, not a little bit less. That way I knew how much I was taking off on these face cuts, because I don't want to take too much, because remember, my minimum thickness for each rotor is 23 millimeters, which comes out to 1.023 inches, and I just want to make sure I have enough meat left on the rotors when I'm done, especially on one side. I want to do one side as minimally as I can. That way, when I go to the back side, I can have enough meat there to get that one fully faced, and then still have some meat overall over the minimum thickness. So of course, always running some coolant when I'm making a pass. And look at that, you actually see a little bit of I guess metal dust, steel dust come off when I rub my finger across, because I was also using some coolant. And so there is a nice, shiny, smooth finish there. And then once again, I'm going back to the indicator, feeding in, so just about 9 thousandths. I don't have to quite take a full 10, because 5, I was like, if I feed in 5 thousandths, I may not get the full face cut. It may still have some skipping in it. So I'll just take about 10 and maybe just 9, because if I take 9 at a time, then if I take 3 cuts, that's 27 thousandths instead of taking 3 10 thousandths cuts, 30 thousandths, because at this point, every thousandth of an inch matters. Every thousandth of an inch matters. Let me say that a little more clearly. And now we're on the back side, and I had to switch the turning tool to facing out, as if you were sticking your finger out and pointing at someone. And it was sticking a little far out of the tool holder, but that I had to do that by design because the tool holder would actually crash into the side of the rotor if I didn't stick the turning tool out far enough. And this is because on the backside, the chuck jaws are in the way. There's no way I could have had the turning tool horizontal like I did on the front facing cut, which I ended up doing because once again, my coworker suggested that instead of just having on the front side, having the turning tool stick out, have it turn sideways. So here I am at 1 and 0.81, 1 and 81 thousandths for the front side. And once I finished that backside, finished facing it, I actually took off another 25 thousandths. So my finishing size on all 6 sides that I checked with the mics was 1 and 56 thousandths of an inch, which is more than my 1 and 23 thousandths of an inch minimum thickness per the specs, which actually say it on these rotors. And then when I looked it up on Google before noticing it stamped on these rotors, both are in agreement with each other in that minimum spec. So the first rotor is done. I am very happy with how it turned out. My coworker said next time I could also just face it all the way to right before touching the hub part and not leave that lip on it. I guess I did not think of that. I was thinking, why not keep the lip, and then I can paint it, and that part won't get rusted either. But he said just go ahead. It's just better just to face the whole thing. That way you don't have a slight lip and a sharp edge potentially. But I did sand down where the lip and the face of the rotor met with sandpaper. Take off that lip, and now I will put some high heat paint on the sections that will not be touched by a brake pad, and then I will be done. So these, fast forward, the other 3 were faced on both sides, and it came out pretty well. It took a long time. Each pass was about 15 minutes long, and I will have a little epilogue video for you that's just showing just a whole pass, just because you might be curious as to literally how long it takes just for one pass, and just imagine how long I was standing at that lathe for all 4. These are the final thicknesses in that box with the check marks on that piece of paper on the left. And here is one of the rotors with a fresh coat of that 500 grain enamel paint. And I would do it to the other rotors. Thank you for watching. This has been part 4. See you in the next video.